In this video, we shall talk about the summary of quadratic functions. We know that the quadratic function takes a form of y equals to ax squared plus bx plus c. Okay? And specifically, the terms of the equation actually mean something. Okay? Where c refers to the y-intercept and the coefficient of a determines the shape of the graph, whether it be a smiley face or a sad face. Okay, so to find the roots of the function y equals to ax squared plus bx plus c, we solve for the equations such that where y equals to 0. Alright, so this can be done by three methods: by factorization, by completing the square, or by the quadratic formula, which is given by x equals to negative b plus minus square root of b squared minus 4ac over 2a. Alright, let's specifically talk about this quadratic function. Okay, where we have x is equals to negative b plus minus b squared minus 4ac over 2a. Okay, the fact that there is a square root here means it has some special properties. Okay, look, what if b squared minus 4ac has three different forms? Firstly, we shall talk about b squared minus 4ac being equals to 0. So if we put it into the function, into the formula, okay, we have this specific term in the end we'll get. Okay, if I were to turn this into 0, entire thing becomes 0, then x is equals to negative b over 2a. Okay, this means that there only exists one real root. Okay, so there exists one real root. Okay, next we are going to figure out what if b squared minus 4ac is more than 0. Alright, so let's take d is equals to b squared minus 4ac. I'm going to make a substitution here because I don't want to write so many times. Okay, and in this case d is more than 0. Okay, so therefore we have x minus b plus minus square d to a, and because of plus minus we have x equals to negative b plus square d to a, or x equals to negative p minus square root d over 2a. Hey, there are two terms. Alright, and because of these two terms, we can say that there exist two real roots. Okay. Lastly, what happens when b squared minus 4ac is less than 0? Okay, so taking this as d being less than 0, we see that square root of d becomes a problem. Why? What happens if you square root a negative number, let's say negative 1? Now, this is not possible because you won't get a real number. The answer is not a real number. Okay, so as a result of this, okay, we can say that x equals to negative b plus minus square root of d to the 2a won't give you a real number, therefore does not have a real root. Okay, alright, next we're going to talk about what does it mean graphically. Okay, so graphically this means a simple thing. Okay, take this to be the x-axis. Okay, this for this first case, alright, it means that the curve just touches the y-axis only once. Okay, and negative b over 2a. Okay, For the second case, okay, where b squared minus 4ac is more than 0, we can see that the curve cuts the x-axis at 2 points. Okay, and for the final case where b squared minus 4ac is less than 0, the curve does not cut the x-axis at any point. Okay, this is the graphical interpretation of the determinants of x. Okay, next. I'm sorry, not determinants, discriminants. Okay, so this can be applied to many different things. For example, when a line cuts the x-axis, okay, solving for, let's say, y equals to mx plus c, y equals to ax squared plus bx plus c, solving for mx plus c equals to ax squared plus bx plus c, okay, we can see also 3 terms inside here. Okay, solving for it right, we can get we can get ax squared plus b minus mx equals to 0. Okay, because c can be cancelled. Okay, in solving for this, we can still use discriminants, okay, to see whether the line intersects the curve at how many points. So if the b squared minus 4ac is equals to 0, this is the line y equals to mx plus c cut y equals to ax squared plus bx plus c at only 1 point. Okay, if it's more than 0, this means it's at 2 points. And lastly, if it's less than 0, it doesn't cut. Not cut the curve. Okay. Finally, when you talk about the quadratic inequalities, okay, where we solve for ax squared plus bx plus c is, let's say, less than equals to 0 or less equals to 0. Okay, any one of these two possibilities. Alright, so this, what you normally can do is similarly like how you solve for this in the root function, but we can also do it over here. Okay, so here we have let's say take an example of 2x squared plus 3x plus 1. Okay, is, let's say, more than equals to 0, and this we can solve for 2x plus 1 x plus 1. Okay, it's more than equals to 0, and you can solve for that being this is half minus half and 1. Oh, sorry, minus half is bigger than 1. 1 and minus half. Okay, and because this is a positive function, so your curve cuts here. Okay, and since we want to find x, this function will be more than 0, so we shall shade the line above the x-axis. Hence, x is equals to, x is more than equals, x is the value less than equals to minus 1, and x is, sorry, is or x is more equals to minus half. Alright, that's the end for this video.